In this video, I am going to share some very important points about an apparatus known as potentiometer. Let us see what is the construction of this apparatus, how it is used, what is the principle of its working. First of all, let me show the construction of a potentiometer. A potentiometer is nothing but this is a wooden board over which four or more than four wires are fixed parallel to each other. At least four wires are there. In some cases, there are six or eight wires. All these wires are of equal length, that is 100 centimeter, and these are parallel to each other. Terminals are provided at the ends, and all these wires are connected to each other through metallic strips. These rectangular boxes represent metallic strips. So this wire starts from here, is attached up to this point 100 centimeter, then strip is there, another 100 centimeter, then 100 centimeter. So in total we can say it is a 400 centimeter length of wire. So all these four wires are connected in series with each other. Let me call this terminal as terminal T1 and this terminal as terminal T2. This is the construction of a potentiometer, and this wire is known as potentiometer wire. For making use of this apparatus, what we do, we connect a battery to the terminals of potentiometer for flow of a constant value of current. This high potential battery is connected between terminals T1 and T2. As a result of this, a current starts flowing in the wire of potentiometer. Another connection is made from terminal T1 and we use a jockey on the other end of this connecting wire. One end of connecting wire is connected from T1, another is connected to jockey that can be slided over this whole length of potentiometer wire. And we also use a galvanometer on this connecting wire portion. This is how this potentiometer apparatus can be used. Now let me share the principle of working of this potentiometer. Suppose I am connecting this jockey J at a certain point on this potentiometer wire. Suppose the length of wire starting from terminal T1 and up to jockey J is L. Question is, what will be potential across this portion of wire? That is to be calculated. According to Ohm's law, potential across this wire can be written as V equal to IR, where I represents current that is flowing through potentiometer wire and R represents resistance of this portion of wire. Now we have to calculate the resistance of this wire. Now resistance of wire can be written as rho L upon A, where rho is resistivity of wire that is used and A is area of cross section of wire that is kept same throughout its length. So using this value of R, we can write expression for potential as equal to I rho L upon A. Now if I is also kept constant, rho and A are already constants, so we can say potential across this portion of wire is directly proportional to L. Larger this length, more will be potential, and vice versa. So this forms the principle of working of a potentiometer, that potential across any portion of potentiometer wire is directly proportional to length of that portion of potentiometer wire. That's all.